All right, section 6.3. What's going to go on this first slide, you might want to write down on a sheet of paper and reference it as you're doing the homework and as you're following along on the examples that I'll do coming up after this. So squares, these are things that can be made by squaring something. So the idea is 1 squared, 2 squared, 3 squared, and then so on. And the numbers you get from that. So 1 squared would be 1. 2 squared would be 4. 3 squared, 3 times 3 is 9. And then 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. And you might even make a little bit longer list than that. And also, we have square variables that start with x to the second, which is basically x to the first squared, x to the first times x to the first. X to the second squared is x to the fourth. And these, the exponents of the variables go by multiples of 2. So 2, 4, 6, 8, 10, 12, and then so on. Basically, if it's got an exponent that's a multiple of 2, then it's a square. So this 1 squared, 2 squared, 3 squared, that was just the thinking that creates the numbers. So cubes, the same idea. You've got 1 cubed, 2 cubed, and then so on. That's where we get the numbers from. So 1 cubed is 1 times 1 times 1. 2 cubed, 2 times 2 times 2. 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed, and then you don't need as long a list of cubes, but you might, again, write these down just so you can reference them. They'll come in handy on the examples in this section. And then cube variables, because you'll see those also. They start with x to the third, and then they go up by multiples of 3. So x to the sixth, x to the ninth, x to the 12th. And then fourth, so it's the same idea. So 1 to the fourth. This is just the thinking. So 1 times 1 times 1 times 1. 2 times 2 times 2 times 2. 3 times 3 times 3 times 3. And then 4 to the fourth power. 4 times 4 times 4 times 4. And as you go, you need less and less of these numbers. And then variables would be x to the fourth, starting with the 4. And then you're doing multiples of 4. So x to the 8th, x to the 12th, x to the 16th. And then 1 to the 5th, which would just be 1. 2 to the 5th, 32. You can use a calculator for these, or like I said, you can just copy these down and then reference them as you're going through the assignment. And then if you take 3 times 3 times 3 times 3 times 3, you get 243. And the variables, if you want to list those, so that goes on. X to the 5th is where you'd start, and these all be multiples of 5. So x to the 10th would be next. X to the 15th. Okay, so number 1, we want to simplify this radical. And one thing that's going to come up periodically is what's called an index. And that's the number that goes in this little nook here. If it's written, then you know what it is. But if it's not written, then you'll just have to assume that it's 2. They don't write 2's in the nook. But you'll need to know that we're talking about the square root, not the cube root or anything else. So in this case, if we're going to simplify this, we're going to look for squares. Because the index is 2. So if you've got your list of squares, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 100 squared, or 10 squared. So you want to check, and you can, if 216 was on the list, that would be nice. But if it's not, then you'll want to start it roughly at about half of 216, which would be about 108. So roughly right around here. And then you want to just basically divide 216 divided by 100 and see if that gives you a nice whole number. Doesn't in that case. 216 divided by 81, 216 divided by 64, 216 divided by 49, 216 divided by 36, 216 divided by 25. Once you get to 36 though, you'll get a nice whole number like 6. So what we'll do is we'll rewrite this as the square root of, instead of 216, we're going to write it as 36 times 6. And then since we're looking for squares and we've got an x variable there, your x squares would be x squared, x to the 4th, x to the 6th, and x to the 4th already is a square, so we do not need to rewrite it. We can just leave it as x to the 4th. And what we'll do from there is we're going to take out everything that's a square. 36 is on the squares list, so we're going to take that out. X to the 4th is also on the squares list, so both of these things are going to come out. So we want to think about what the square root of 36 is. Square root of 36 is 6. And then the square root of x to the 4th. And what you'll want to do with the variables is you're going to divide by the index. The index here is 2. So when you take that 4 divided by 2 on the outside, this is going to be x to the 2nd. 4 divided by 2. And then the 6 is not a square. It doesn't have any squares in it, so it stays inside the radical. And that's how we simplify that. Number 2, cube root of 162 times t to the 8th. So largely doing the same thing here, only we've got an index of 3. So we're going to be looking for cubes. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. And you can also make a list of the variables, x to the 3rd, x to the 6th, x to the 9th, and then so on. But 162, so if we had 5 cubed, 6 cubed, would be 216. So 162 is not a cube. In some cases, they may give you a number that's already a perfect cube. But since 162 is not, you start at about half of it. That'd be about 81. So 125 is too big, and we can just go through these. So 162 divided by 64, and we'll see what that gives us. Doesn't come out nicely. 162 divided by 27. That gives us 6. So we're going to rewrite the 162 as 27 times 6. And then the t to the 8th. T to the 8th is not one of the variable exponents that we have, but we could rewrite it as t to the 6th, since t to the 6th is a cube, times t to the 2nd. And the way we get the second is you want those exponents to add to be 8. So 6 and 2 add to be 8. And the 27 is a cube. The t to the 6th is a cube. Those are going to come out. And not just the 27 and t to the 6th, but the cube roots of those. So the cube root of 27 is 3. Cube root of t to the 6th. Remember, you're going to divide that by the index. So 6 divided by 3. And then the only things that were left inside are the 6 and the t squared. And be extra careful that you put that 3 in that little nook area. Otherwise, it looks like a square root. But it should be 3t squared and then the cube root of 6t squared. Number 3, square root of 32a squared b. Index here, if it's not written, it's 2. So we're going to be looking for squares in order to simplify this. So hopefully you've got your squares list that you can reference while you're doing this. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and then you've got x squared, x to the 4th, x to the 6th, and then so on. So looking for those. 32 is not on the list, so we're going to start at about half of it. Start at about 16. And if you do 32 divided by 16, you get 2. So that's a nice whole number. We'll rewrite the 32 as 16 times 2. And then looking at the a squared, you may need to rewrite it, but since x squared is on the list, we can just leave it as a squared. And then b is too small to have an x squared in it, so it doesn't have any squares. So we'll just leave it as b. And then the parts that are going to come out are the 16, since it's on the squares list. The a squared is on the squares list. And then you'll want to take out the square roots of those. So the square root of 16 is 4. And then remember, with these exponents, you're going to divide by the index. Index is 2. So when you take that out, it's going to be a to the first. 2 divided by 2. You don't need to write the 1. You can just write a. And then on the inside, we had 2 that didn't come out, and we also had b that didn't come out. Number 4, the 5th root of 96, x to the 7th, y to the 10th. So here we're going to be looking at that last column that we wrote down in the first slide. Not a lot of numbers to look at here. We've got 1, 32, and 243. 243 is obviously too large to fit into 96, so we'll try 32. And if you do 96 divided by 32, you actually get 3. So we're going to rewrite 96 as 32 times 3. And then with our variables, we started with x to the 5th, x to the 10th, x to the 15th. We're just going to see if any of those, x to the 7th not on that list, but we can write x to the 7th as x to the 5th times x to the 2nd. So that'll together make x to the 7th. And then y to the 10th, we don't need to rewrite it because it's already on the list. Y to the 10th. And then once you've done that, we can see all the ones in there that we'll be able to take out. And so we'll just highlight those, the x to the 5th, the y to the 10th. All of those are coming out. So let's go back here just a little bit. Okay, so when we're talking about the 5th root of 32, you basically just have to count. I mean, this is 1 to the 5th, this is 2 to the 5th, this is 3 to the 5th. And so the 5th root of 32 happens to be 2. So that comes out, the x to the 5th, when it comes out, remember to take that exponent divided by the index, so x to the 1st. And then for the y to the 10th, this is going to be a 2, 10 divided by 5. Then we're just going to rewrite what's left. So we had 3 left inside, we had x to the 2nd, and then be extra careful again that you don't forget that number that's supposed to go in that little nook area. Number 5, square root of 5 times the square root of 15. These are butted up against each other, which indicates that we're going to multiply. So when you multiply these, you do need the same index to multiply. And on both of these, since it's not written, remember that the index is 2. So they do have the same index, so we can multiply both of these. 5 times 15 is 75. And then if we want to simplify this, we're going to look for squares. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. Just have to go to about half of 45, so roughly around 36. So take 75 divided by that. That doesn't work out. 75 divided by 25 ends up being 3. So we can rewrite 75 as 25 times 3. And then this square root of 25 is going to come out. That's going to be 5 on the outside. And then the square root of 3 we don't know, so we'll just leave that on the inside. Number 7, doing the same thing. We're multiplying these radicals since they're butted up against each other. They do have the same index. And since they have the same index, we can multiply the numbers inside. So 3 and 15. Multiply those, and then we've got b to the third doesn't have anything to multiply with. C to the fourth doesn't have anything to multiply with. Then we're going to simplify by looking for squares. So 1 squared, 2 squared, 3 squared, 4 squared. Start at about half and then work your way up. So half of 45 would be roughly around 25. 45 divided by 25 doesn't work. 45 divided by 16 doesn't work. 45 divided by 9 gives you 5. So we can rewrite the 45 part. And then the b cubed, remember with your squares, x squared, x to the fourth, x to the sixth. So b to the third wouldn't be on that list. The biggest square on that list would be b squared times b to the first. Or you can just write b. b to the first is the same as b. And then c to the fourth would be on that list. So you can leave the c to the fourth as it is. And we'll just take out everything that's a square. So the 9's going to come out. That's a square. b to the second is a square. Anything with an exponent of 2. C to the fourth is a square. Anything with an exponent that's even. So all those things are going to come out. Keep in mind that your index is 2 there. So square root of 9 on the outside. And the b to the second, when it comes out, 2 divided by 2. Divide the exponent by the index. So b to the first. And then when we take c out, c to the second. And only 5 and b were left on the inside. Number 7, 4th root of 6 times the square root of 5. These are 2 as they are. Again, if we're going to multiply radicals, we need the same index. The index on the second one is 2. So since they have different indexes, we'll have to do a little bit of rewriting this. And the way that we do this, since we have to multiply the index by 2, and each exponent inside by 2. So we're going to have a 4 in that little nook there. And since this is 5 to the first, we're going to multiply that exponent by 2 also. So this is going to be 5 to the second. Okay, so multiply the index by 2 in order to get our indexes the same. And then we've also got to multiply every exponent inside by 2. So the 4th root of 6 stays the same. And we'll go a little bit further with this. 4th root of 6, and then the 4th root of 5 squared is 25. Now they have the same index, so we can multiply them. Get 150. And at this point, you'll want to look at the list that we wrote down at the beginning. You've got 1, 16, 81, 256. Obviously, 256 is too big to fit in 150. You can try 150 divided by 81. 150 divided by 16. And we don't really do anything with 1. So none of those came out as a whole number. So this is actually as simplified as it's going to get. Number 8, square root of 5a cubed b times the 4th root of 125ab to the second power. So again, we're butting up against each other 2 radicals, so we're multiplying. And if we're going to multiply the numbers inside, the indexes need to be the same. Here the index is 2. So just like on the last one, we're going to multiply by 2 so that our indexes will be the same. And we've got to multiply each exponent inside by 2 also. So multiply by 2. So now we've got the 4th root. Now this is 5 squared, which is going to be 25. We're going to multiply this 3 by 2. And the exponent on the b is 1. So if you multiply it by 2 now, it's going to be squared. And the second one already has the index we want, so we don't need to change anything inside. So now we can go ahead and multiply these. We end up with 25 times 125. And when you multiply the a's, we've got a to the 6th on the left. We've got a to the 1st on the right. So when you multiply those, we're just going to add their exponents, adding the 6 and the 1. And then same with the b's. Okay, and then once you've got everything multiplied underneath one radical, you do want to look to see if you can simplify it. Hopefully you've got your list 1, 16, 81, 256. And on this one, a little bit of a hint, you will need to add one more number to this since 3,125 is a pretty big number. And if you do, we started with 1 to the 4th power, 2 to the 4th power, 3 to the 4th power, 5 to the 4th power, or 4 to the 4th power, and then here 5 to the 4th power. This does actually go into 3125. Let's see, 3125 divided by 625. That comes out to a nice 5. So we can rewrite this as the 4th root of 625 times 5. And then if you've got your variables there, x to the 4th, x to the 8th, x to the 12th. B to the 4th would work since it's got the same exponent. A to the 7th, though, is not on the list. The largest that we can fit in a to the 7th would be a to the 4th. But since we're rewriting a to the 7th, we've got to make sure that this still comes out to a to the 7th. So a to the 4th times a to the 3rd, still a to the 7th, but now we can see the square that's in it. And then b to the 4th power. So some of these things are going to come out. The 625 is going to come out. The a to the 4th is going to come out. And then the b to the 4th is going to come out. So the 4th root of 625 is 5. 5 times 5 times 5 times 5. The a to the 4th, when it comes out, you're still dividing by the index. So 4 divided by 4 is a to the 1st. Also taking out that b to the 4th. And then on the inside, we've got 5, and we had a to the 3rd. Okay, number 9. Square root of 490 over square root of 10. Anytime you've got a square root on top of another square root, try to reduce this if you can. And then 490 over 10, that does reduce. 49 divided by 10, or 490 divided by 10 equals just the square root of 49. So all that underneath the square root. And then the square root of 49 just comes out to 7. So not too bad on that one. Number 10, cube root of 64 over 27. Again, if you've got a fraction underneath some sort of radical, you'll want to reduce if you can. 64 and 27, though, you might run through the numbers. 64 is even, so 2 goes in, but 27 is not even, so 2 doesn't go into that. Not a whole lot of things that go into 27. 9 goes into 27, but it doesn't go into 64. 3 goes into 27, but it doesn't go into 64. So not able to reduce on this one. And once you've looked at that, go ahead and split up the radical. So starting with the top number, cube root of 64, and then we'll also do the cube root of 27. And the nice thing about both of these is 64, if you look back at your cubes list, 64 is on it. 64 is a perfect cube. Also, if you look back at your list of cubes, 27's on it. It's also a perfect cube. So cube root of 64 is 4. You could do that on the calculator, or you could just count your list, just starting with the first one. Cube root of 27 is 3. So a little bit easier, those problems.